Good morning, students. In the last class, we discussed about the some problems regarding the mole concept. So in today's class, I'm going to solve another one problem which is very important for 3 marks, 4 marks. They ask how many marks they want. Okay, it is very big problem because comparison is more and very important. That is based on limiting reagent. Which one is the limiting reagent? How much left in excess? How much product is found? So I'll solve that problem. Very important. Taken the problem based on limiting reagent, that is 50.0 kg of N2 and 10.0 kg of H2 are mixed to produce NH3. Calculate the NH3 formed. Calculate the NH3 formed. Identify limiting reagent. Identify the limiting reagent in the production of NH3 in this situation. This is the problem. So students listen. Here the given the formation of NH3 by the combination of N2 and H2. And in that they are going to ask you to find out which one is the limiting reagent, whether H2 or N2. Okay. So initially for this you need a balanced reaction. Initially to this you need a balanced reaction. Which reaction it is? N2 combines with H2 gives rise to NH3. So all are gaseous reaction, no doubt in that. So students here, to balance that, this is the reaction. Okay. So here the given, listen, 1 mole of N2 requires 3 mole of H2 to form 2 mole of NH3. Here the question is, how many NH3 is produced by reacting 50 kg of N2 and 10 kg of H2? The given weight of what? This. So in the given weight, we can easily calculate number of moles. Initially, these are given in what? Kg. We have to convert it into grams. Understand? So here listen. First, initially, the first step 1 I will say, step by step. It is in gram, 50 gram means no need to convert, but it is in kg. But 1 mole of nitrogen, its mass is 28. It is in gram, not in kg. Either convert this to kg or this to gram. Better we can convert this to gram. Okay, so listen, 1 kg is equal to 1000 gram. Okay, here 50 kg they given is equal to how much? Okay, so how much it is? Okay, N2 in x gram I will take. I'll take x of N2. We have to mention now. Okay, so in gram, x is equal to 50 into 1000. Okay, simply if you take this is 5 into 10 to the power of 4 gram. Correct? So this is 10 raised to 3, 50 is there, 5 into 10 to the power of 4 gram. Similarly, this is first one. Second one, similarly convert H2. So 1 kg is equal to 1000 gram. 10 kg of H2 is equal to Y H2 gram. Just a comparison. The gram of N2 is taken as X, unknown we don't know. Gram of H2 is taken as Y because it is unknown. So Y gram is equal to how much? 10,000 into 10, that is 10 to the power 4 gram. Initially, this is converted into what? This. Next, step 2. Number of moles. How many? Number of moles are there. Okay. How to calculate number of moles? It is given mass divided by molecular mass. Listen, just compare. We have N2. So 1 mole of N2 means is equal to 28 gram of N2. 1 mole is equal to 28 gram of N2. Here how many gram is there? 5 into 10 to the power of 4 gram given mass. Okay, so this is 5 into 10 to the power of 4 gram of N2 is equal to how many grams? Okay, as I told you, number of moles of N2. What is this become what? 5 into 10 power 4 divided by 28. Correct? Listen, given mass divided by atomic mass or molecular mass. That is what formula I said. How this formula is obtained? By comparing these equations. Okay? If you do 5 divided by 28, you will get okay, so it is 0.17857 into 10 to the power of 4. So students, I just shift this here, that is 17.86 into 10 to the power 2. Understand? Are you correct? 1.79 into 10 to the power of 2. Understood? Whatever you want, you can take. This depends on you. The powers are here. Similarly, number of moles of H2. Directly I will write given mass by molecular mass. Given mass of H2 is how much? The given mass is 10 kg. That means 10 raised to 4 gram. That is 10 to the power of 4. That is 1 into divided by mass of that is 2. Mass of H2, hydrogen is 2. So answer we will get is 1 divided by 2. Sorry. Okay. 1 divided by 2 is 0.5 into 10 to the power of 4. Arithmetic 50 into 10 power 2. Okay. Students, you take here 1 digit I take 1.786 into 10 to the power 3. This is 5 into 10 to the power of 3. This is what? Number of moles of H2 and number of moles of N2. This is what? First step, initially conversion. Second step, calculation of number of moles. Understand? So the next one is here comparison with equation. Step 3 is comparison. Okay? How we have to compare? Listen. 1 mole of N2 here. 1 mole of N2 requires how many mole of H2? 1. Nothing is there means 1. So 1 mole of N2 requires how many mole of H2? Hey, how many moles are there? 3. So 1 mole of H2 requires 3 moles of, 1 mole of N2 requires 3 moles of H2 to produce 2 moles of NH3. Understand? That is the balanced reaction. That is always each and everything is compared with standard value. Given value is compared with what? Standard value. Here, 1 mole of N2 requires 3 moles of H2. 3 moles of H2. Here, 1.786 into 10 power 3 moles of N2 is there. How much? 1.786 moles of N2 means how many moles of H2 we require. Okay, so if you calculate moles of H2 required is equal to, okay, if you cross multiply, what you will get? 1.786, sorry, here 10 power 3 is there. Okay, 1.786 into 10 to the power 3 into 3, you know, cross multiplication, divided by 1. So if you multiply 1.786 into 3, you will get 5.358 into 10 to the power of 3 moles. Understand, students? Here we require 5.358 into 10 to the power of 3 moles. This is how much we require to react with 1.786 into 10 power 3 moles of N2. But the availability of H2 is only 5. Extra 0.358 we require. Understood? Here we require is 5.358. Here the availability is only 5. That means this is the limiting reagent. The reagent which is present in less amount in the reaction. Understand? The reagent which is present less amount in the reaction, that is called as limiting reagent. Compared to this and compared to this, so if you cross multiply, students, if you consider this result, just for your comparison I will say, okay, 1 mole of N2 is equal to 3 mole of H2. Okay, here we have 5 into 10 to the power of 3 moles of H2. Okay, listen. If you compare this, you will get mass of N2 is equal to 5 divided by 3 into 10 power 3. So 5 divided by 3 means it is 1.666 into 10 power 3. To neutralize or to react with 5 moles of this H2, we require only 1.66 gram of 1.66 moles of N2. But availability is 1.78. It is excess. Understood? This is the reaction. How to find out the limiting reagent? This is just a comparative reaction. Don't bother about that. Okay, students. So this is the moles of H2 required is 5.358 into 10 power 3 moles. So next, by comparing with, listen. Once we got this means, next step 4, compare NH3 and H2. Okay, so here 3 moles of H2 means, here 3 moles of H2 reacted means how many moles of NH3 is found? Is equal to 2 moles of NH3. Correct? Next, here the mole we have is this much. 5 into 10 power 3. So 5 into 10 power 3 moles of H2 is equal to how many moles of NH3? Okay, so the moles of NH3 is equal to, if we cross multiply, we'll get 2 into 5 into 10 to the power of 3 divided by 3. Okay, that is 10 divided by 3 means we will get approximately 3.33 into 10 power 3 moles. This much of NH3 is produced when it reacts with 50 gram of N2 and 10 kg of, 50 kg of N2 and 10 kg of H2. Okay, so the last step is, the question is, okay, calculate the NH3 form. We have to calculate in gram or kg. That is in kg. Okay, we have to convert it into gram or kg. It is in mole. Then how can you compare? Compare it with 1 mole. So 1 mole of NH3 is equal to 17 gram, because nitrogen is 14, hydrogen is 3, total 17. So 1 mole of NH3 is 17 gram. Here how many moles are there? 3.33 into 10 power 3 moles. Then how many grams? Okay, so then mass of NH3 produced is equal to, if we cross multiply, we will get 3.33 into 10 power 3 into 17 divided by 1. Okay, so that 3.33 into 17, you will get 56.61 into 10 to the power of 3 gram. Okay, that means 56.6 kg. 10 power 3 means kilo, you know. So 56.6 kg of NH3 is produced. Understand, students? Understood? So this is the steps you are going to do in the examination. This is because, you know, by seeing, I will show another one easy way to do this. But in the examination, if they ask for 3 marks, you have to follow these steps. Initially, conversion from kg to gram or gram to kg. Next, number of moles calculation. In that, find out the which one is the limiting reagent. Here, listen, which one is the limiting reagent here? Which one is the limiting reagent here? H2. Because H2 we require for this term, this much of N2 is 5.358. But the availability of H2 is only 5. Okay, so this is less in number, means this is the limiting reagent which controls the product formed. Understand? The very important problem, almost all, so many times only this problem is repeated for your examination. Only this. They used to change, instead of this 50 gram, 50 kg, they used to give 2 gram. Understand? Instead of 50 kg, they used to give 2 gram. Once they give 2 gram, this step is not required. Because there is no kg, there is no conversion. So it directly go to this. If the given weights are in gram, no need to convert it. So step 2 is the step 1. Means number of moles. 1 mole of N2 means 28. 1 mole is equal to 28 gram of N2. Here they given 2 gram. Here they given 2 gram. Then how many moles? Okay. If 2 mole, 1 mole they given assume. So number of moles of H2 is 2 gram. Okay. If they given 1 gram, then how many moles? Understand? So like that, you have to compare. That depends upon the value students. Almost they used to give This is very tough, 50 kg is there, 10 kg is there. Always they used to give 2 gram, 4 gram, 5 gram like that, which made you to calculate easy. So it starts from step 2. Initially conversion to moles, moles to comparison. Among the comparison, which one is excess, which one is less. Listen how to compare. Here you have obtained moles. Next, you have to calculate how many amount of H2 is required for this, N2 is required for this individually. How many moles of H2 is required for this mole, correct? Similarly, how many moles of N2 is required for this mole? I did that, 1.66 you got the answer. Here, instead of this, by taking, if you take 5.5 to 10 power 4, sorry, 10 power 3 of H2 means you will get the amount of N2. Understood? So then you can easily came to know which one is present in excess, which one is present in less by comparing with this. Okay? So here N2 is, for this, N2 we require is 1.66. That means this is excess, this is in less quantity, this is in excess quantity. That means this is the limiting reagent. Okay, then this is the step 4, because we require what? How much ammonia is produced. So limiting reagent means, of course, the product is depend upon the concentration of the H2. Understood? So we have to compare this with this. Okay, so this is all about the problem. Very important. As much as possible, we just simplify that. These are the steps. Next, so these only questions are very important indeed. How to solve that? I'll just see in this equation by step only. Okay, so listen. Because most of the question is based on this concept only, moles only. In that, especially limiting reagent. How? Which one is present in excess? How many grams? Which one is present in less? How many grams it varies? How many moles? Okay? If you know the comparison from mole to gram, gram to mole, mole to volume, then you can easily solve the problems. So listen students, here initially they given how much? 50 kg of N2 reacts with 10 kg of H2 gives, you just compare. Here listen, 1 mole of N2 combines with 3 moles of H2 to give 2 moles of NH3. Okay, here the number of moles. How to calculate number of moles? Okay, so listen, the given mass of H2 requires, this is 50 kg, this is 10 kg, this is question, because we have to find out when these two react with this amount, how much NH3 is produced in that question, correct? Next, so divide this given mass by molecular mass. What is the molecular mass of N2 for 1 mole? That is 28 gram it is. This one is 2 gram. This one is how to calculate number of moles. So students listen, this is in kg, this is in gram. So you can easily convert this to gram by multiplying with 10 power 3. Correct? So number of moles you will get is 50 divided by 28. You can easily calculate 50 divided by 28 is 0.0 1.78, I'll take this much only, into 10 power 3 moles. This one is 5 into 10 power 3 moles. Okay, listen here. So here produced this question. This one you already got. Number of moles you got here only. Number of moles is equal to 1.78 into 10 power 3 moles, 5 into 10 power 3 moles. Third step, comparison. 1 mole of N2 is equal to 3 mole of H2. Here, N2 value is 1.78 into 10 power 3. So, how much H2? Similarly, 1 mole of N2 is equal to 3 moles of H2. So, this one, 5 into 10 power 3 moles of H2 is equal to how many moles of N2? You can easily calculate both H2 and N2. Okay, then you will get X gram or N2 gram into moles. Moles of N2 required is equal to how much? Not N2, this is H2. Moles of H2 required is 1.78 into 3 into 10 power 3. 1.78 into 3 means that is 5.35 into 10 power 3. This is what number of moles of H2 required. Here, number of moles of N2 required. Number of moles of N2 required. Here N2 required is what? 5 divided by 3 into 10 power 3. So 5 divided by 3 means, as I told you, 1.67 into 10 power 3. So this is what required. Now compare students here. 0.78 gram of N2 we have, but we require only 1.67. So this is in present in excess. 1.78 is more compared to 1.67. This is the required value. This is the presently we have. Okay, that means this is present in excess. Next, this one, compare. We have 5 into 10 power 3 mole of H2, but the required is 5.35. So 0.35 is less with us. So that means this is the limiting reagent. In this, they are going to find out. Listen, they ask how many H2 we require in excess? 0.35 mole. So 0.35 mole into mass of that gives the mass of H2 required in excess. Understand? Next, how many gram of N2 left after reaction? Means to form this reaction, to form NH3 students, we use only 1.67 into 10 power 3 moles of N2. So from this, if we minus, that is 1.75 into 10 power 3 minus 1.67 into 10 power 3 means, so 0.11 into 10 power 3, we will have 0.11 into 10 power 3. Excess of NH3 is present, excess of N2 is present after reaction. After completion of the reaction, so I will say here, I'll write this simply. Listen, after this reaction, this is initial value assumed. Final value means, so 1.78 into 10 power 3, in that 1.66 into 10 power 3 is reacted. Here, 5 into 10 power 3 is there, in that completely it is reacted. 5 into 10 power 3. Understood? So then, here excess left is 0.11 into 10 power 3, here it is 0. Then, here we will find the final value, that is 5 into 10 power 3 into moles of NH3 will form, because the number of moles of this is the number of moles of NH3 formed. Understood? This becomes 2 into 5 into 10 power 3. Why? Because 2 moles. Understood? Sorry, not 2 by 3 moles. Because comparison, 2 moles is there, 1 mole of NH3 if we compare, H2 is there, either it is 3 by 2 or 2 by 3. By comparison, you can easily see. Understand, students? So listen, so this one is left in excess, this one is completely reacted, the product is formed. How much N2 is required left in excess? How many grams? So number of moles is here. Grams means what? Number of mole is equal to what? Given mass by molecular mass. So given mass we want is very important. Mole to gram, mole to mass, mole to volume, mole to number of atoms. Understand? So and remember, moles of grams we can easily calculate. So I will write some formulas. With respect to atoms, how to calculate number of moles. Those formulas are important for you and I teach. So listen, number of moles is equal to given mass by atomic mass. First formula. Next, number of moles also equal to given mass by molecular or molar mass. Okay, next, number of moles is equal to given volume by molar volume. That means either 22.4 liter or 22,400 cm3 or 22,400 cm3. Yeah. 22.4 dm3 or 22,400. Yeah, right? So students, you may take it in meter, dm cube, ml or cm cube. That's your choice. Okay? Given volume divided by this. If you want to convert it into liter, you have to take this. Into ml, you have to take this. Into dm cube, this. Into cm cube, this. Next, number of moles is equal to number of atoms given divided by 6.023 into 10 power 23 atoms or molecules or ions. So this is our comparison. Okay? How to compare? I will say listen. For each I will give one example. Okay, for first one, I'll take calculate or directly take number of moles of 6 gram of carbon. Okay, number of moles for 6 gram of carbon. So students, carbon it is an atom. So the formula is number of moles is equal to given mass by atomic mass. So given mass is how much? Given mass is 6. Molecular mass, sorry, atomic mass of carbon is 12. Okay, so number of moles for 6 gram of carbon. Given mass is 6. Atomic mass is 12. That is 0.5 mole. Okay, next here. Number of moles for 80 gram of NaOH. Okay. So student, given mass of NaOH here is 80. Molecular mass of NaOH if you calculate. Na atomic mass is 23. Oxygen atomic mass is 60. Hydrogen atomic mass is 1. That is 40. So this is 80 divided by 40 means 2 moles. Okay. 0.5 mole. This is 2 moles. Next. Number of moles given volume by 22.4 liter. Okay. So for example, I take number of moles of 1500 ml of water. 1500 ml of water. So students, given volume is 1500 divided by in ml what it is? ml is the like 22,400. Okay, into 1000. Why? Because 1000 ml is equal to 22,400. Sorry. Okay, you can calculate easily. Not 1000. So this is 15 divided by 224. If you divide this, students, you get 0.066 moles. 0.066 moles. Okay, that is moles. Okay, next. Number of atoms given to the Avogadro's number means number of moles of 18 molecules of water are not 18. Okay, 18 molecules of water you take. Okay, so given molecules is 18 divided by Avogadro number is 6.023 into 10 power 23. Correct? So students, number of atoms is this 023 is just neglect that 6 ones are 6 threes are. That is 3 here 0.23 means approximately 2.9 into 10 power minus 23 atoms are molecules. Molecules needed. Not molecules, this is mole. 2.9 into 10 power 23. This is all about what? If the number of moles should be calculated in atomic mass, molecular mass, volume, and as well as number of atoms. This comparison for you is very, very important. At what time, at which question, which of the comparison we are going to apply, whether gram or volume or kg or atoms. Understood? So this is all about. So remember always, if any question is there, listen, if they give 50 kg of N2 reacts with 100 molecules of H2. Remember, 50 kg of N2 and 100 molecules of H2. Molecule is different, gram is different. So we cannot compare them, but we can convert them into number of moles. Moles is same. If number of moles we know, then we can easily calculate the product formula, excess reagent, limiting reagent, everything. Understand? So this is all about the limiting reagent and the mole concept. So students, why I explained this topic is very, very important for theory as well as NEET or any competitive exams. Okay? Understood? So the next one is The solutions, the reactions in solutions. If solution is there, the solution will be, 10% sugar solution, 10% acid solution, 10% or 25% acidic solution, basic solution, you are going to say. That means 25% acidic solution means 25 ml of acid present in 100 ml of water. Understand? 10% sugar solution. 10 gram of sugar present in 100 gram of water. That is percent solution. Similarly, 1 molar, 0.5 molar, 2 molar like that. Okay? How we can calculate? So, 5 types of reactions are there. One is mass percent, one is volume percent is also there. Okay? Another one is molarity. So, these are the reactions which are occur in what? That reactions. Sorry. Okay, reactions. Chemical reactions are there, solutions are there, in that molarity is there, mole fraction is there, mass percent is there, volume percent is there. Understand? So in the tomorrow's class, we will discuss with the reactions, means the reactions occur in solutions. Okay?